learning vector quantization. Here this question is asking LVQ is used to classify 4 input vectors xk and their respective classes tk for k is equal to 1 to 4 into two classes such that t1 is equal to t2 and t2 which is equal to c1 which is equal to 1 and t3 is equal to t4 which is equal to c2 which is equal to 2. Let the two initial weights for classes c1 and c2 be selected as w1 is equal to x2 and w2 is equal to x3, assuming that 1. All the 4 input vectors are to be presented orderly as x1, x2, x3 and x4 in each iteration. 2. An immediate update is applied to each weight vector within each iteration, and 3. Updates are carried out in all the weight vectors with equal minimum distances. From an input vector given the initial gain value g of 1 is equal to 0.3 and g of t plus 1 equal to v g of t, and for t greater than or equal to 1, show the step-by-step calculation for the value of the sum of all the differences between elements obtained by subtracting w2 from w1 as w1 minus w2 at the end of the first iteration using g of 1. Submit your answer rounded to 2 decimal places. Given x1 is equal to 001, x2 is equal to 011, x3 is equal to 110, x4 is equal to 100. Okay, so now let's see how to do this problem. So our final goal is calculating the w1 to w2, and here we have 4 iterations because if you see we have x1 to x4 and k is starting from 1 to 4. We had to do the 4 iteration and we had to update w1 and w2 values each time and finally we have to calculate the value. Now let's go ahead and do step by step. First, let's create a table. Here we have k starting from 1 to 4 and also we have 4 x values, and then they have also mentioned that t1 and t2 are equal to 1 and t3 and t4 is equal to 2. So we have to put a table for these informations. Okay. I divide the tables as well. I need 4 spaces, 1 for the title and 4 for the elements. Okay. Now first we are going to look at the k values, and then we are going to looking at the x values, we call it xj, and the t values tk. K value, the range is given to us 1 to 4. So 1, 2, 3, 4, and x1 is 001 for the first one, and then the second one is 011, and the third one is 110, and then the fourth one is 100. Okay, and the tk, they have mentioned that this t is for the first one and second one is just 1, so these two are 1, and for the third one and fourth one is 2. Okay, now we have the table, and the next one is the gain is provided to us, which is 0.3 g1, g of 1 is 0.3. I will go to the next page and put it right there. Gain given to us is 0.3, the equal sign, and also they have mentioned in the question that is w1 is equal to x2, w2 is equal to x3. So w1 is equal to x2 and w2 is equal to x3. And if I look at the x1 value, w1 is equal, okay, actually x2 value, w1 is equal to x2 given to us, which is 011, So we put 0 1 1 here, and then w2 is equal to x3. If I look at the x3 value, which is 1 1 0. Okay, now based on this information we can start the iteration number 1. Iteration number 1. Okay, for the iteration number 1 we can say x1 of t1. We are going according to the table. First we are going to have x1 of t1, x2 of t1 again, and then x3 of t2, x4 of t2. These are the 4 iterations we have to do. And in order to do this one, we need the x1 first, which is, you look at the table, that is 0 0 1, and then the w1 and w2 also needed. W1 is 0 1 1, w2 is 1 1 0. Now what we do is we calculate the distance. So the distance between w1 and x1, we call it d1. Okay, and you have to look at like w1 minus x1, like 0 minus 0 here. So 0 minus 0 square, and then plus 1 minus 0 square, plus, and then 1 minus 1 square. This is going to be 0, and this is going to be 1 minus 1 square, which is just 1, and then 1 minus 1 square, which is 0. So we are going to get 1 here. And then for the d2, we look at the distance between w2 and x1. Again, you have to think like w2 minus x1, like 1 minus 0, 1 minus 0 square, plus 1 minus 0 square, plus 0 minus 1 square. But I think even if you do opposite way, it doesn't matter, because since you are squaring, it's always going to be a positive one. If it's 0, it's going to be 0. So 0 minus 1 whole square. Okay, then 1 minus 0 square, that's 1, and then 1 minus 0 square, 1. 0 minus 1 square is negative 1 square, which is also 1. That's going to give us 3. Okay, now we have to compare which one is smaller. So d1 is smaller than d2. So if it happened, then we have to update the w1. If the d1 is smaller, we have to update the w1. If d2 is smaller, we have to update the w2. So here this d1 is smaller, so we have to update the w1. We can also mention here, since tk of cj tk is equal to cj, update w1. The way we update the w1 is we take the w1 and equate this one to whatever the w1 we have previously, which is 0 1 1, and then we apply the gain 0.3 gain, and then we multiply the difference between x1 and this x1 and w1. The x1 is 0 1 1. Actually w1 minus, hold on, yeah, x1 minus w1, which is 0 0 1 minus w1, which is 0 1 1. Okay, so this is what we have to do. Let's simplify this one. Now I had to multiply, I had to do the difference and multiply. This one we can keep it as it for now, and then here this is 0.3 times 0 minus 0, which is 0, then 0 minus 1, which is -1, and then 1 minus 1, which is also 0, and then this 0.3 multiply here and become this one -0.3 right here. Okay, if it's -0.3, then when we add this is 1 minus 0.3, this is going to be a 0.7, so we are going to end up having 0, 0.7 and 1 right here for the first weight vector. Now the weight one is W1 is updated, which is 0, 0.7, 1. Now what you have to do is we have to carry this one and do the next iteration. So let's call the iteration number 2. In the iteration number 2, what we look at is we look at x2 of t1. Okay, so in order to do this one, we need a x1, actually x2. We need the x2 here, which is 0, 1, 1, and we need the w1 and w2 as well. But here the w is going to be the updated w, because we already updated the w1. We had to bring this value here. W2 remains the same because we didn't change anything for the W2. So the W1 will be whatever we updated here, which is 0, 0.71. And the W2 is going to be this one, 110. Now we follow the same step. We calculate the distance between this, like the way we did before. Like we had to look at the distance between x2 and w1, so that is 0 minus 0, 0.7 minus 1. Like you have to square all the way as well. So let's do it one more time, and I'm just gonna do these two, and then I'm just gonna do it quick and complete it. Okay, just you have to just pick up the pattern. So it's gonna just follow like this. D1 is gonna be 0 minus 0 square plus 0.7 minus 1 square plus 1 minus 1 square. So 0 remains 0 right here, and then plus 0.7 minus 1, which is 0.3, which if you square this one is 0.09, and then 1 minus 1, which is 0, so we're going to hit 0 here. So altogether we end up getting 0.09 as the answer for this one. And if you calculate D2, we have to look at the distance between W2 and X2, and then again 1 minus 0 square plus 1 minus 1 square plus 1 minus actually 0 minus 1 square. Okay, now 1 minus 1 square, which is 1, 1 minus 0 square, 0 square is which is 1, 1 minus 1 square, which is 0, and then 0 minus 1 square, which is going to be 1. So here we get 2. Now we had to compare these two values, 0.09 and this 2. Which one is smaller? D1 is definitely smaller again. D1 is less than D2. So we had to update W1. If the D1 is smaller, we had to update W1. If the D2 is smaller, we had to update W2. Okay. Since TK is equal to CJ, update W1. Updating W1 is same process. Like you have to take the W1 and then like if you look at this one here, we take the W1, that is 0, 1, 1, and then what we do is we multiply by the gain of the corresponding X value. In this case, this is 0, 0, 1, and then minus the W1 again. Same thing here. The only thing difference that's gonna happen is now we are gonna have X2 instead of X1 here. The X changes, right? Here we have X1, that's why we have 0.01, but here we have X2, so we are gonna have 0.11. Other than that, it's gonna follow exact pattern. So if we update W1, then W1 is gonna be, the initial W1 is 0, 0.71. So that remains here, and then that one plus the gain multiplied by the corresponding X value, which is 0, 1, 1 in this case, minus the W value, W1 value, which is 0, 0.71. Now we have to just calculate this. So 0.71, we can keep it as it is. And then here 0 minus 0, 0, 1 minus 0.7, that is 0.3, and then 1 minus 1, that is 0. So only the 0.3 in the middle remains, and that one multiplied by 0.3 here, that's going to be 0.09. So we are going to have 0, 0.09, and then 0 again. Okay, and if you add this, you're going to have 0, 0.79, and then 1. And this is the updated W. Okay, so now we can go for the iteration number 2. Actually, iteration number 3. We already did the 2. Iteration number 3. Okay. So iteration number 3, we have to look at the table. Number 3 is x3 of t2. So for this one, we need the x3 value, which is 110. And we need the W1 and W2. Now W1 is updated last in the last ones, which is 0, 0.791. Zero, 0.791. And W2, we didn't touch W2, we didn't change anything in the W2. It remains the same, which is 110. Okay, now I think you kind of pick up the pattern. So always what we do is we calculate the distance first. The way to calculate the distance is, if it's D1, we are looking at the X value and the difference between X value and the W1 value, and then we square them. Like for this one, 0 minus 1 square plus 0.79 minus 1 square plus 1 minus 0 square, and you add them together. And then so if you calculate that value, you are going to end up getting 2.0441. And then for the D2, what you do is you calculate 1 minus 1 square plus 1 minus 1 square plus 0 minus 0 square. So here the whole thing is going to be 0. So now you compare which one is smaller. D2 is definitely smaller in this case. If D2 is smaller than D1, then we have to update W2. In the previous one, we had D1 is smaller, so that's why we kept updating the W1. But here the D2 is smaller, so we update the W2. And we can also mention, since TK is equal to CJ, update W2. And the way to update W2 is, what you do is you put the W2 value first, which is 110. and then you put a plus sign, and then gain, which is 0.3, and then you multiply that one by the corresponding x value, which is 110 in this case, and then you subtract the W2 value, which is 110 as well. So as you can see, this is going to be 0 because it's equal values. So we are just going to end up having okay, let me double check this one. Yeah, so nothing changed in the W2, it remains 110. Okay, that's our W2. Then the next, we go to the next iteration number 4. Here, look at the table, x4 of T2. And then we have to bring the x4 value, which is 100. Now the W1, we have to look at the last W1 value, which is we brought it here as well, 0.791. And then W2 value still remains the same because in the last one nothing happened, 110. Okay, again you calculate the distance. The way to calculate the distance is you look at the W1 and distance between x, which is 0 minus 1 square plus 0.79 minus 0 square plus 1 minus 0 square, and if you square and add them, you're going to end up getting 2.6241 for this. And then D2, you look at the distance between W2 and x4, which is 1 minus 1 square plus 1 minus 0 square plus 0 minus 0 square, so which is going to be just 1. And then what we have to do is we have to compare which one is smaller. Here again D2 is smaller than D1. If D2 is smaller, we have to update W2. And we can also mention here that since TK is equal to CJ. Okay, so now we have to update the W2. Updating W2 is we bring the W2 value, which is 110, and then we put a plus and then multiply by the gain, and then we put the x value, corresponding x value, which is 100 in this case, and then we put a minus and then put the W2 value again, which is 110, and then we calculate. This one remains the same, 110 here, and then plus 1 minus 1, which is 0, 0 minus 1 minus 1, and then 0. So we're going to have a minus 1 in the middle, and multiply by 0.3, which is going to be 0, negative 0.3, 0. Okay, and then when you add them, you're going to have this one turn into 0.7, so we're going to have 1, 0.7, and then 0. Okay, this is our final W2, 1, 0.7, 0. Because only 4 iterations we need to do, and we did all of them. Because according to table, we only have 4 iterations, and we did all of them, and our final W1 is this 0.791. We can mention it here. W1 is 0.791, and W2 is this one, 0.70, 0.70. And at the end, according to the question, we have to calculate w1 minus w2. So w1 minus w2, which is 0.791 minus 1 0.70, and if you calculate this one, you're gonna get 0 minus 1, which is minus 1, and then 0.79 minus 0.7, which is 0.09, and then 1 minus 0, which is going to be 1, and then finally you have to just add them together, sum of elements, which is negative 1 plus 0.09 plus 1, and that gives us minus 1 plus 1 cancels each other, so we are going to end up getting 0.09, and that's our final answer. Okay, and that's how we do this kind of problem. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next